This is my new project. It's a floating sensor assembly, which immediately you can see there are problems. If the camera sees a rectangle, these distance measuring sensors are not centered. I mean, regardless of where they are, there will be offset. So you have to factor that in. But with regard to the scale of the robot and this navigation thing, the size of whatever object you hit has to be, so big anyway. Although with this camera and OpenCV and different angles, hopefully you can pick out like a stick, something that's not a convenient blob. This is the whip, as you say. So this will have its own power supply. It'll just be a single cell, boosted up to 5 volts. There'll be an ESP here. It'll drive these servos. There will be an API that says forward, rotate both forward, back, and then turn. So here's all the parts for the floating sensor assembly. Got a camera. Let's see, what is this? Oh, these are the bearings. I just looked up small bearings on Amazon, and these are 4mm inner diameter. So you got a step-up power supply for the single cell. Got a Pi 2 or a Pi 02. This thing's a quad core. It's a beast. Because OpenCV single core really does badly. Got a TF Mini LiDAR. This time don't strip the freaking connector. Got this is range time of flight sensor, Hololu. There it is. Same old. Got a BMS. I'll use one for the single cell. A charger. Got a switch. I like those physical switches. Then this is the 6050 accelerometer gyro. The entire unit's going to be like a slab that does that, and this thing will be at the exact middle of it. So I briefly want to go over how you do the circuitry. This stuff is all pretty simple because they're breakout boards and they have standards and everything's big. So let's do 2 lines. This side will be the floating sensor assembly. This will be the robot. It's my cat. So this is the TF Mini S time of flight ranging servos. Got a Pi and a camera. Volume of your battery. Step up module. So the battery is 3.7 to 4.2. And all of these parts operate at 5 volts. So you have to use this step-up DC-DC boost module. That gives you 5 amps, or not 5 volts, 2 amps. And then you feed all of that into the parts. And then the TF Mini will use serial, so you just find serial pins on the pi 0. And the time of flight we'll use probably I squared c, because that's what I've used before. And then the robot, it has 2 servos. You have the same thing, another single cell battery. Step it up, and it drives these. And then the ESP, if it runs, it probably runs on 3.3. In that case, you would have a step down regulator. I'll use a linear one, because if you use like the ones with the transformers, they could be like bad feedback to use 2 of them together, like a step up then step down. You don't have to quote me on that, but yeah. So, and then what'll happen is, here's the robot. The wheel drags itself platform. And the sensor unit will be here. Still not come up with like a box or frame or something for it, but it'll be in something. And then it rotates for the pitching, so it can look down and up where it wants to look. And then how it works is there'll be a API in the ESP32, and then the Pi, they'll talk like this, and that's how the Pi will do all the thinking, and it'll just command the robot to go forward, backwards, left, right. It's a basic 2D platform, like an RC car. I also want one of these calipers so you can accurately measure things. The 3D printing is in millimeters, but I still design in inches. Other thing I want to mention is the design isn't like super accurate. It's primarily just physical modeling, and then that allows you to like lay out where things are going to be in 3D. So the thing I'm designing is pretty much an improved version of this. There was a TF Mini S here, but I took it out. And there's your camera. Same deal, it's just instead of the camera being up here, it'll be in the middle. Sensors are on the side. And the entire thing, they share the same plane. This one, the 2 distance measuring sensors had their own like plane, and then the camera, you'd have to do some like trig to offset the, you know, like the center of rectangles here. This points up or down, it makes a triangle. So yeah, and I'm just looking at how I made this thing before with the pan tilt, like one of them holds the other. So this is the sensor plane. They're 0.9 inches apart. No reason for that. I just try to give it enough room, but not too far apart. It's funny, like that doesn't look the same as that one. But the reason is it's 0.9 from the center point of the sensors. Anyway, so those are all on the same plane. Let me see. Yeah, I'm basing it off the surface of the board. It's not like 100%, you know, like maybe the wave or light is generated here. There's definitely some like air. Same for the camera. With the camera, it's like a giant rectangle. These all in pre-flux, so it's pretty easy to. Just gotta go through and make them filleted. Confirm. No accidental connections. Just a quick check-in on this. I still don't exactly know how this thing's gonna look in the end, but what I'm doing is I know where all the mount points are, so I'm making like pegs for them. I'll extend them, then there will be some kind of body for these things to attach to, and I'll probably use like screws or glue or something, you know, nothing professional, but yeah, I'm still trying to size things because, for example, you see this IMU plate here, but it doesn't have the connections on it, the pins, and that takes up space, volume, so you have to like plan for where the wires are going to be, how much space they're going to take up. Getting a little more closer to something tangible. One thing I forgot about is the ribbon cable. So it's actually convenient, it works. So it's standing up like that, and then the camera just goes over. No strain on the ribbon. It's just hard to hold with one hand. So I've got a idea how this thing's gonna work. There is a horizontal bracket that holds it. That's the pan tilt. And then there's a vertical bracket that's attached to that, and it goes like this. It includes whatever's inside. And you can see here, like, that plane is the tilt plane. So I don't really know anything about gears. I remember I had to design some like in a drafting class, but I just want something that won't lose grip, and it's 1-to-1 ratio, and the diameters are roughly 0.66 inch. So I'm on this site, Evolent Design, and what I'm doing is I'm like physically scaling how big it is, and I'm checking the size of the teeth just based on how small my 3D printer can print. So this one has 16 teeth per gear at this diameter. That looks pretty good. SketchUp, this one 2017 is pretty old. It's a piece of shit. It's like it starts to lag. I don't know, it's my fault. Like, I'm not paying for it. I'm not. It's 2017, like it's old. This is the thing with 3D designing. It's like, look how tiny that is. It looks huge and virtual. So I did forget about the servo and the gear. Like, that takes up space. So I gotta figure out where to put it, where it can rotate the entire plane. Probably like angle it or something. I actually have this backwards. This gear has to be attached to the thing that's not moving, and this gear rotates from the servo. It'll rotate about this axis. Since the servo is attached to this plane, it should rotate everything around it. Oh crap. I just need a 1-to-1 rotation transfer. I don't know if these half-S gears are going to be accurate enough to like pitch 1 degree exactly, or if it's going to be like every 4 or something, but I've jumping ahead with the electronics here. So I'm powering the Pi. At the bottom of the USB power in, there's positive and negative taps. And then I made these little breadboard servo things until I gotta confirm that the command of the servos through the Raspberry Pi is going to be reliable. It should be, I hope it is. But so this boost converter has a little potentiometer you turn. It goes super high, like 17 volts or whatever. So I gotta probe it with a multimeter, turn it all the way down to like 5 something. I go over 5, just so there's a little bit. So we got 5.31. So this power bus is all wired up. Pi 0's on. I believe it's on the network. I ARP scanned and I see it. So I'll use it and then I will test the I found how to command servos with Python, so I'm gonna try that out. So right now I'm having problems getting the Pi to connect to Wi-Fi. It's usually a trivial thing. It's even built into this Pi imager thing now, but it's not working. So I ended up having to connecting it to external monitor. That's weird, it was already like logged in. But I had to use Raspberry config using this old Raspberry Pi keyboard. It's not the full computer one, it's a literal keyboard. I almost forgot to install the BMS. Oh man. The battery's not protected, so I gotta put that on there. This thing is so cute. Look at it. Tiny little Chromebook. Finally, I'm getting good use of this thing. So battery terminals go on the outside, and the output goes on in the middle. That's if it's good enough to work. This is sick. This Chromebook here is gonna write code on there and control it. In the end, I'll write on the desktop with a big screen, but so this right here kind of sucks. If I spent time and designed a bevel gear, this servo could be flat and like lie on this hand mount, but I don't really want to deal with calculating like the multiplying factor due to the non-1-to-1 gear ratio with regard to the angle it moves. So I just made a mistake. I forgot that if this entire thing tilts, then this servo gets detached. It'll rotate with the body. Ah, crap. Yeah, I gotta think about that. Since this thing won't rotate like more than 90 degrees and it goes back and forth, I think it's okay to have some wires come out. So the problem with doing it like this is now you gotta route wires in here and they're gonna stop this thing from moving smoothly. That's why the thing has to be floating, quote unquote. I think I'm just gonna go with it. This is the first version. The problem with this one is the TF Mini S, the wires were really stiff, so it was hard to accurately aim. And also there's no IMU on the pan tilt, so without encoders you can't tell the angle this thing is at. So actually I think this will work. The base of it, the servo is attached to the entire body, the entire pan tilt plus cross thing, and there will be a like female, actually you don't really need the gear to be here, but already like printed them and attached them, so I'll just print like a female one that this slides into, and then there's a bearing there, bearing here, this thing pan tilts. There will still be a like coil of wire that goes to this servo, but everything will be inside, and it just has to like swivel left to right, and that will be okay with this. That shouldn't add like much resistance. So right now I'm just bridging all the parts together. There's no like planning yet. I'm just trying to get some kind of solid internal skeleton that I can mount stuff to and see how it fits. So about a day and a half later or whatever, I got about what I need to start printing. Got everything laid out. I'm kind of just randomly attaching things. Like I know where the parts need to be, so I'm just putting plastic that would hold it up. This thing is gonna take 4 hours to print. My God. The other thing is if I'm done designing, I can finish interfacing with all the sensors. I've already like done it in the past, so I just have to pull the code together and make some basic libraries and confirm they'll work. Plug them into the GPIO. This is like the nastiest thing I've ever designed and tried to print. Like, look at I just joined like everything, and then all the sensors, camera stuff gets attached. IMU is in there in the middle. Ooh, this is gonna take some cleanup too, but the battery is held like by this saddle, and it just drapes over, and it'll like swing downwards, but this is where like the Pi processor and stuff will be. So this is the first print of the cross. It was at 80%, but it failed because I put a little like notch that stuck out in the support that Kira made was on this slope, and it broke off. So I just started dragging stuff because, you know, it couldn't print on something solid. But it's okay because that's cool. This is really flimsy, so I beefed that up along with some other dimensions. Yeah, I generally extruded it upwards so it's a little stronger, and I beefed up these edges.